Hello, and welcome back to Grizzly Adams Mathematics. I'm your host, Tony Weathers, Professor of Mathematics at Adams State University in Alamosa, Colorado. Previously on this channel, we investigated noteworthy historical examples of mathematicians estimating the value of pi using what are essentially geometric techniques. Today, picking up in the mid-17th century, we turn our attention toward more analytical approaches to estimating the value of pi. We'll begin with a contemporary of Isaac Newton by the name of John Wallis. Now, John Wallis was a clergyman, but quite a good mathematician in his own right. He made several contributions to the history of calculus, and you probably know him best as the fellow who introduced the infinity symbol. He also did a lot of pioneering work in continued fractions, but we're not going to get into that here. Let's talk about Wallis's infinite product. In 1655, in the Arithmetica Infinitorum, he considers a quadrant of the unit circle, which is what we would write as the following definite integral. Now, because he knew the area of this thing was pi over 4, he used a series of arithmetical tricks to establish the infinite product shown here. While this is a very interesting historical curiosity, this product converges much too slowly to be of any real use. Next up is the Scotsman James Gregory. Among other things, he was a mathematician and an astronomer, and in 1663 he published Optica Promota, which describes the construction of a reflecting telescope that would eventually come to be known as a Gregorian telescope. Later, he would publish works on geometry, including these two, the last of which appears to be the first systematic attempt at a calculus textbook. By 1671, he had figured out a relationship that is written like this in modern notation. By performing the long division indicated on the left-hand side, he came to the following infinite series. Oddly enough, this is as far as Gregory seems to have pushed this idea. This brings us to the estimable Gottfried Leibniz, co-discoverer of calculus. By 1674, he had discovered the same series as Gregory. However, he took the additional step of substituting x equals 1 into the series, which led him to this. Perhaps Gregory didn't consider the special case since its convergence, which was a concept introduced by Gregory, was too slow to be of practical use. Newton himself came up with a concept that is written in modern notation as follows, and then used series expansions to arrive at this. Substituting in x equals a half, he came up with the following series for pi over 6. Using this series, Newton generated the following approximation for pi, which is stunningly close. How close, you ask? Well, although Newton computed 16 decimal places, only the first 14 are correct. Percentage-wise, his answer is off by an absurdly small amount. It's worth noting that although these eminent mathematicians were making important progress regarding pi itself, none of them were referring to pi as such. The mathematical world would have to wait for William Jones, a self-made mathematician for that particular development. Jones, who wrote on both navigation and mathematics, was another contemporary of Newton's, who edited some of Newton's published works. In 1706, Jones published a new introduction to the mathematics, where he investigated the circumference of a circle, which he refers to as periphery. Letting A represent the length of a 30-degree arc of the unit circle, he writes the following. 6A, or 6 times something that we recognize here as a series, the beginning of a series from one of the previous slides, is equal to 1/2 of the periphery, and here pi. Okay, so this is the first known use of the symbol pi to represent the number that we know it to be today. Nobody really took notice of this until Euler began using pi in 1736. The next contributor we will consider is Ludolf von Ceulen. Working in the latter part of the 16th century, von Ceulen published 20 decimal places of pi. He would later expand this to 32 decimal places, but he died before publishing them. Fortunately, his wife published the results after his death. Strangely, it seems that even by this point he had calculated 35 places, which were published by Snell in 1619. His fellow Germans were so impressed at Van Kuylen's efforts that to this day, pi is often referred to as the Ludolphine number. At this point, the race is on. In 1699, Abraham Sharp published 72 decimal places of pi, followed 7 years later by John Machen, who published 100 decimal places. Not much longer after that, 127 places, then 140 decimal places, then 200 decimal places, then 248, then 440. Next, we'll consider the efforts of William Shanks. This is a picture of him right here. It turns out that calculating digits of pi was a bit of a thing for him. Later, in the same year that Rutherford calculated 440 decimal places of pi, he collaborated with Shanks to extend his calculation to 530 decimal places. Later still that year, Shanks would extend this to a whopping 607 decimal places, of which the first 500 were independently verified. Finally, in 1873, Shanks produced his furthest reaching work when he published 707 decimal places, the culmination of decades of effort on his part. And here we see the 707 decimal places of pi as computed by William Shanks. Seeing all the digits here in one place really drives home the magnitude of his accomplishment. However, as some eagle-eyed observer has no doubt noted by now, there is an error right here in the 528th decimal place. Now, with a wave of the magic wand, we replace the offending digit, and now we have the first 707 decimal places correct. Fortunately for Shanks, this error was not found until well after his death, so he never knew about his mistake. In fact, it wasn't until 1945 that this error was discovered by D.F. Ferguson. After catching the error, he went on to calculate up to 620 decimal places, followed in relatively short order by 710, then 808, then a whopping 1120 decimal places. By 1949, computers entered the fray and were used to compute 2,037 decimal places. From this point forward, progress becomes too rapid to really make much sense of. The current record, which was set in March of 22, is 100 trillion decimal places. If you're having trouble imagining a number that large, consider this. According to my measurements, in 12-point Times New Roman, this string of digits would be about 132 million miles long. Commas, by the way, would add about 20 million miles. As always, thanks for watching, and watch this space for more videos in the future.